ABAP programs can only access a database table correctly if the runtime object of the table is consistent with the structure of the table in the database. Each time the table is changed in the ABAP dictionary, the system checks during the activation when the runtime object is updated, whether it has to adjust the database object to the changed ABAP dictionary definition of the table. The database structure does not have to be changed for certain changes to the ABAP dictionary. For example, you do not have to change the database structure when the order of the fields, except key fields, in the ABAP dictionary is changed. In this case, the changed structure is activated in the ABAP dictionary and the database structure remains unchanged.
The database table can be adjusted to the changed definition in the ABAP dictionary in the following ways. By deleting the database table and creating it again, the table in the database is deleted, the inactive table is activated in the ABAP dictionary, and the table is created again in the database. The existing data in the table is lost. By changing the database catalog, alter table, the definition of the table in the database is simply changed. The existing data is retained. However, indexes of the table may have to be built again. By converting the table, this is the most time-consuming way of adjusting a database table. If the table does not contain any data, it is deleted from the database and created again with its new structure. If data exists in the table, the system attempts to adjust the structure with alter table. If the database system used is not able to do so, the structure is adjusted by converting the table. The following example illustrates the steps carried out by the system during a conversion. Starting situation: the Table tab was changed in the ABAP dictionary. The length of field 3 was reduced from 60 to 30 places. As a result, the ABAP dictionary has an active field 3 with a length of 60 places and an inactive field 3 with a length of 30 places version of the table. The table in the database corresponds to the active version in the ABAP dictionary, which means that field 3 currently has 60 places in the database. A secondary index with the IDA11, which was also created in the database, is defined for the table in the ABAP dictionary. The table already contains data. The following steps are illustrated in figure Conversion Process 2. Step 1. The table is locked to prevent further structure changes. If the conversion terminates due to an error, the table remains locked. Before the conversion is completed correctly, this lock mechanism prevents any further structure changes which may lead to loss of data. Moreover, all views dependent on the table are inactivated and therefore blocked. Step 2. The Database Table tab is renamed QCM tab. The new name of the table is defined by the prefix QCM and the original table name tab. During the renaming, all secondary indexes of the table are deleted.
The following steps are illustrated in figure Conversion Process 3. Step 3. The inactive version of Table tab is activated in the ABAP dictionary. The table is created in the database as table QCM8 tab with the new structure and a primary index. After this step, the database contains the following tables. Table QCM tab with the old structure. This table contains the business data. Table QCM8 tab with the new structure. This table is empty. Caution: the table does not exist in the database with its original name during conversion. As the programs that access this table cannot be executed, make sure that no applications access the table to be converted during conversion.
The following steps are illustrated in figure Conversion Process 4. Step 4. The data is loaded back from table QCM tab to table QCM8 tab. The conversion is done using statement move corresponding. Both tables contain the data after this step. If you reduce the size of the fields, for example, the extra places are truncated when you reload the data. Since the data is in both tables QCM8 tab and QCM tab during the conversion, there are greater storage requirements. Before converting large tables, therefore, you should check whether sufficient space is available in the corresponding table space. A database commit is performed after 16 MB when you copy the data from table QCM tab to table QCM8 tab. The conversion process therefore needs 16 MB of resources in the rollback segment. The existing database lock is released with a commit and then requested again before the next data area to be converted is edited. When you reduce the size of keys, only one record can be reloaded if there are several records whose key cannot be distinguished. It is not possible to say which record this will be. In this case, you should clean up the data in the table before converting it.
The following steps are illustrated in figure conversion process 5. Step 5. Table QCM tab is deleted. Step 6. Table QCM8 tab is renamed to tab. The secondary indexes defined in the ARBAP dictionary for the table are created again. The views on the table that we deactivated in the first step of the conversion are reactivated in the database. Step 7. The lock set at the beginning of the conversion is removed. As the data exists in both the original and temporary tables during conversion, the storage requirements increase. If the table space overflows when you reload the data from the temporary table, the conversion terminates. In this case, you must extend the table space and start the conversion in the database utility again. If you shorten the key of a table, for example, when you remove a key field or shorten the field length of key fields, this may result in duplicate records with the same key. When you reload the data from the temporary table, only one of these duplicate records can be loaded back to the table. It is not possible to predict which record is loaded back to the table. If you want to copy certain records, you have to clean up the table before the conversion.
If a conversion terminates, the lock entry for the table set in step 1 of the conversion process is retained. The table cannot be edited anymore with the maintenance tools of ARBAP Dictionary, Transaction SE11. A terminated conversion can be analyzed with the database utility using Transaction SE14 and then resumed. The database utility provides an analysis tool that you can use to find the cause of the error and the current state of all the tables involved in the conversion. You can usually find the precise reason for the termination in the object log. If the object log does not provide any information about the cause of the error, you have to analyze the system log using Transaction SM21 or the ARBAP dump analysis using Transaction ST22.
Append structures allow you to append fields to standard SAP tables and structures without modifying the table definition. An append structure is a structure that is assigned to exactly one table. There can be several append structures for a table. When a table is activated, all the active append structures for the table are found and their fields are appended to the table. If an append structure is created or changed, the table to which it is assigned is also activated. Like all structures, an append structure defines a type that can be used in ARBAP programs. As of Release 4.6c, you can define foreign keys for fields that already exist in the table using an append structure. Search helps can also be attached to fields that already exist in the table. Hint: if you copy a transparent table in the ABAP dictionary to which an append structure has been added, the fields of the append structure are converted to normal table fields.
Customers create append structures in their namespace. The append structures are thus protected against overwriting during an upgrade. The new versions of the standard tables are imported during the upgrade. When the standard tables are activated, the fields contained in the active append structures are appended to the new standard tables. When append structures are added to a table, you do not have to manually adjust the customer modifications to the new SAP version of the table using transaction SPDD during the upgrade. As the order of the fields in the ABAP dictionary can differ from the order on the database, a conversion is not necessary when you add an append structure or insert fields in an existing append structure. The structure is adjusted when the database catalog is adjusted, that is, alter table. When you activate a structure in the ABAP dictionary, the definition of the table is changed and the new field is appended to the database table.
The new version of the standard SAP table is activated and the new field is appended to the database table. Note the following restrictions regarding append structures. No append structures may be created for pooled and cluster tables. Tables containing a long field data type LCHR or LRAW cannot be extended with append structures. This extension is not possible because long fields have to be the last field of the table. The fields in the append structure must be in the customer namespace beginning with YY or ZZ. Using the customer namespace prevents name conflicts with future table fields delivered by SAP. If as a partner you have your own reserved namespace, it is recommended that you choose the names for your append structures from your namespace.
Structures and tables that have been defined by SAP in the ABAP dictionary can be enhanced by the customer in the following ways. Customizing includes. With this variant, certain places within a standard structure or table are reserved by SAP for customer enhancements. The customizing environment supports customers using these customizing includes. Using appends. With this variant, any fields without previous reservation are appended to the end of structures or tables. Enhancements using append structures may cause the following problems. Structure enhancements affect not only the enhanced structure itself, but also all dependent structures that use the enhanced structure as an include or substructure. However, when the enhanced structure is included in a dependent structure, this can lead to fields in the dependent structure being displaced. This is the case, for example, when the include appears in the middle of the dependent structure. The field displacement can prevent ABAP programs from reading the structure correctly. In programs with deactivated Unicode checks, structure enhancements can lead to syntax and runtime errors. These errors are generally found in type checks and in connection with deep structures. In programs with activated Unicode checks, structure enhancements affect additionally value assignments, operand checks, and accesses with offset and length. For example, numerical or deep components are inserted into a purely character-like structure. Enhancements may also cause some issues because the fragment view is changed. And checks in assignments and comparisons that are based on this are affected as a result. With structures and tables with includes or substructures, the enhancement categories of the includes and substructures cannot be larger than those of the initial structure. For example, if the initial structure contains an include of level 4, levels 2 and 3 are not permitted for the initial structure. Structure enhancements in the dictionary can also have an effect on internal structures in ABAP programs if dictionary structures in the source text are used as type, include, or substructure. These dependencies are considered implicitly in the ABBA program check. These dependencies also relate to non-classified structures that contain enhanceable includes or substructures.